Finding angles. So up until now, we've been given the angle and one of the sides, and we need to find the other side. But it's also possible for us to be able to find the angle. If I were to approach this question like I normally would, I start by labeling the sides. Here's my right angle, so my hypotenuse is opposite it. Here is my reference angle, so 15 is next to it, so that's adjacent, and this is my opposite side. I remind myself of SOHCAHTOA. The sides involved in this question are A and H, so that means I'm going to be using cos. So I write down my relationship, cos theta equals A over H. Then I substitute in the things I know from my diagram. Theta is called theta in this situation. A is 15, H is 26. Now, if I had an equation like this, what I would do to solve for x is I would do the inverse operation of multiplying by 4, which is dividing by 4. I can't divide by cos because the cos isn't multiplying the angle, it's a relationship between the angle and the other sides. But I can use an inverse operation, and that inverse operation is just called inverse cos. And it looks like cos to the power of -1, but it's not to the power of, it means inverse. So on your calculator, so I would go to the trig menu again, and you can see that inverse cos is there in the bottom line. Inverse cos of 15 divided by 26, close the bracket, press enter. We remember that we don't want it like that, we normally want it to some number of decimal places. So I go to Document, Settings and Status, Document Settings, change my calculation mode to approximate. So then I can copy the calculation and press enter, and that gives me that theta is approximately equal to 54 degrees. So in these examples, we're asked to do a similar thing. First, we're just going to practice using our calculator for these. So for A, I have inverse sine, so trig menu, inverse sine of 0.6. Close the bracket, press enter. I'm asked to give that to the nearest degree. And I can see that before actually I forgot to round. That should have been 55 to the nearest degree. This one to the nearest degree is 37. Inverse cos, so trig menu, inverse cos, 0.412. Close the bracket, press enter. This to the nearest degree is 66 degrees. And the final question, inverse tan of 2. Oops, I didn't need to press Control there. Inverse tan 2. Close the bracket, press enter. That gives me 63 degrees to the nearest degree. Pause the video now while you have a go at question 1. And here are your answers. So these questions are similar, but you've just got to interpret them to know what to do. So find correct to the nearest degree the angle theta for which sine theta equals 0.8. Now, if sine theta equals 0.8, then I just need to inverse sine both sides of my equation. So theta equals inverse sine 0.8. So trig inverse sine 0.8, close the bracket, press enter. To the nearest degree, that gives me 51. So theta equals 51. Similarly, if cos theta equals 0.2, then I need to inverse cos both sides. And so theta equals inverse cos 0.2, which trig inverse cos 0.2, close the bracket, press enter, 74 to the nearest degree. For f, if I type inverse cos of 2 into my calculator, it says undefined. Now you might remember from last lesson, cos of theta and sine theta are always between for the ones we're doing, we're always between 0 and 1. So anything that's greater than 1 is undefined. Pause the video now while you have a go at question 2. And here are your answers. Okay, so our working when we're finding angles in triangles follows a similar pattern to when we were finding lengths in triangles. So we start by labelling each side. This is my reference angle, so this is adjacent and this is opposite. We remind ourselves of SOHCAHTOA. In this situation, I'm using the opposite and the hypotenuse, so I'm going to be using sine. So I just write out my ratio statement, then I substitute in what I know, then I inverse sine both sides. And put that into my calculator. Trig menu, inverse sine, 8 divided by 12, close the brackets, press enter. So here I'm asked to give it to the nearest degree, so this one is 42. Label the sides. Hypotenuse is always first. This is my reference angle, so this is adjacent, this is opposite, we're not bothered about that. I'm interested in adjacent and hypotenuse, so I'm going to be using cos. So I write down my cos statement. This is beta equals A over H. Actually, my statement is normally cos theta, isn't it? Then I substitute in the values I know. Then I inverse cos both sides. And then I put that into my calculator. Trig menu, inverse cos, 9 divided by 16, close the brackets, press enter. So that's 56 to the nearest degree. Finally here's my right angle, label the hypotenuse first. Here's my reference angle, so this is adjacent and this is opposite. I'm using opposite and adjacent this time, so that's going to be tan. Write down my tan ratio. Substitute in the values I know. Inverse tan both sides. Put it into my calculator. Twelve over 5. So that's 67 to the nearest degree. Alpha equals 67 degrees. Okay, now you should be able to do question 3. Make sure you mark your work as you go, or when you get to the end of the question, here are the answers. Thank you.